All right, perfect. Rohan, absolutely brilliant. To have you here. This topic of robotics and how it connects to sort of like physical AI and the real world is a topic that I've wanted to cover for quite some time. Just haven't really found somebody who can discuss a topic that esoteric and still make it, interesting and engaging. So thanks a lot for volunteering to do this. Why don't we
Yeah,
start?
thank you for having me.
Yes, absolutely. Why don't we start at the very beginning? Could you tell us a little bit about your career journey, some of the different roles you had, and specifically would love to know a little bit more about your interest in robotics and a little bit more background on Figure AI and what the company does and what you do there.
Yeah, so I think I got interested in robotics when even before undergrad, actually, I always had this kind of um, interest that got peaked when I think Google released their self-driving car, like what used to be Waymo. It used to be a part of Google X at the time. So Google X released their first self-driving car, and that was like my first. I think I was somewhere in like somewhere from eighth grade to 10th grade, something like that. But yeah, I was like, oh, that was my first exposure to a real robot that's like out there, and of course it was very early stages, and now it's like it's been so long now. Waymo has started to operate in the Bay Area and Los Angeles and stuff like that. But yeah, so anyway, I did my undergrad in computer science, and I felt like even then, this was in like 2015, I could see that um, the rise of machine learning was starting to. I felt like it had a lot of use cases within robotics. So I started working in like a robotics lab in undergrad, and I realized that at least at the time, for a lot of these mobile robotics, I was working on robots that move around autonomously. The bottleneck was perception, and the biggest problem that, or the biggest solution that people had for perception was um, machine learning, right? Like just collect lots of data, train stuff on it. Anyway, so yeah, I started working on that. Then I kind of went deeper and deeper into like computer vision, perception. After that, got a job. Actually, even in undergrad, I started like an autonomous driving club in our college, and I think we were perhaps like one of the first people to show like a level 2 autonomy in India, like on an Indian car. So level 2 autonomy is like there are different levels, but it's like adaptive cruise control and lane following, and yeah. And after that, worked in a couple of robotics companies. Um, for agriculture, defense, lots of different applications. And now, yeah, finally ended up at Figure, where, yeah, I think my work currently is training the AI models that help the robots work autonomously. So yeah, that's kind of what I'm working on right now.
Awesome. Thanks a lot, for that background. And we'll talk, of course, a little bit more about what Figure's been doing of late and what's
Yep.
interesting in terms of the work that y'all are doing. But maybe we start off by zooming out a little bit, right? By trying to understand not just what's happening in robotics today, but how things have evolved over the near term, right? And to try and understand what's been happening. Maybe one thing that you could do for us is give us a little bit of a sense, right? Like you spoke about a certain timeline starting back in the 2000s when you mentioned Google X and the self-driving car. But if you walk back even earlier, give us a walkthrough of the timeline, right? Of, on one axis, we were to think about some breakthroughs in robotics innovation or robotics capabilities, and on the other axis, you think of it from a time perspective. What's been happening? Where are we now? Also, in terms of, the holy grail that people are trying to achieve in terms of like, truly autonomous robots, you end up with like iRobot and Terminator and all of that from a slightly sci-fi perspective. But give us a sense, where are we on that timeline? What's happened in the recent past? That's notable, and where might we end up in the near future? Would love to get a sense over there.
Yeah, I think so the in my mind, the way I see it, the fields of AI, which includes like computer vision, natural language processing, and robotics, they have followed a very analogous journey. And what I'll describe for robotics, it's like largely true for computer vision and for natural language processing as well. So I think like robotics started in like 50s, like 1950s, 1960s. It's that old. People made like the first industrial robots. They made robots that you could program in a very limited way. So you could only define some starting positions, ending positions. You would record some trajectory and then just replay that trajectory again, right? So that was like the first robot that could just do work in a repeated way. Then I think in like 70s, 80s was like when classical control techniques were born. So that was when people were like, okay, if I know, like if I want to move the robot in this particular way, if I have a robotic arm, how do I move it? What's the math behind it? And people develop, like now it's standard, it's taught in all robotics courses. It's like forward kinematics, inverse kinematics, things like that, PID controls. It's very standard. So those were developed in like the 70s and 80s. I think in the 1990s is when mobile robotics became popular. So moving away from just rigid, uh, like they're called robot arms are called manipulators in the industry. So like moving away from rigid manipulators to like uh, self-driving. Self-driving is still a big word, but at the time it was more, can you have a robot that perceives the environment around it and figures out how to move. So that was when some other techniques like mapping, simultaneous localization and mapping, SLAM, that's a big area these days. That's when that was born. Autonomous vehicles, I think, came from like a lot of interest from NASA, like space programs. So that was like 1990s. And then 2000s, I think, was when some of those self-driving and things like that actually began to take shape. So there was a big program by DARPA. DARPA is like the US Defense Research Organization, kind
Yep,
of like
yep.
US counterpart of DRDO. So DARPA made this program. I forget what was it called. It was very classic. DARPA Grand Challenge is what it was called. So they had like different universities and research teams and so on compete in like making a car drive itself from, I forget, some large distance. And then they had another challenge, which was the DARPA Urban Challenge, which was like, I think DARPA Grand Challenge was like kind of in an off-road setting, but DARPA Urban Challenge was, okay, how do you make it drive in a car in a city and like follow traffic rules and stuff like that. So that's when that started. Um, um, in parallel in the 2000s, a lot of like early humanoids. I think Boston Dynamics started sometime around then. All these guys started to take shape. Um, and then I think 2010s is when like the first like people started applying machine learning into robotics. So people, because 2012 was like the big breakout moment for deep learning. So people were like, hey, like deep learning is doing so well in like handwritten digit recognition, image classification. So why don't we use it to recognize and parse the environment around a robot? So that's when people started doing that. Reinforcement learning, etc., other techniques like that came into the picture where you could learn things from simulation. And I think like 2016, yeah, so this was like the 2010s, and then now I think 2020s is where we've kind of taken the lesson from ChatGPT, right? Which is that the techniques that made something like ChatGPT work, and again, this is the same in NLP, computer vision, etc., everything, right? Is that all of these fields had very rich histories in the going back to like 50s, as early as 1950s. Um, and I don't want to say like, of course, those techniques are still useful, but people realized that if we can adapt these techniques to build algorithms that get better with data, that gives us a clear strategy to just then it becomes very easy to improve them. It's just like add more data, add more compute, scale everything up.
Yep, yep, yep.
So from the 1950s, so this is true in computer vision, NLP, is that all these classical techniques inspired some machine learning, deep learning based techniques for each of these fields, which kind of were developed in the 2010s. And now in the 2020s, we are in the stage of like, okay, we have the algorithms. Now let's just scale it and see what happens. So I think I find it very interesting that like OpenAI's journey kind of made that possible because
Hmm, hmm.
OpenAI was like, hey, like NLP, we have machine learning is working. Like we have one model for image translation, one model for like emotion recognition, we have one model for whatever. Why don't we just like make a huge model, just train it on as much data as we can get our hands on and see what happens, right? It was a pretty, it sounds obvious now, but it was a pretty revolutionary idea at the time.
Hmm, hmm.
OpenAI seemed like a very risky company, like they were taking a pretty risky bet to make all this infrastructure, collect all this data, spend all this money training these large models. But now, in hindsight, it seems very obvious. And I think that's where like a lot of people, once it happened in LLMs, now it's coming in, like it's already happened in computer vision. People have made like foundational models for vision, which can do like a lot of different tasks, segmentation, object detection, tracking, face recognition, everything can be done by one model. And so naturally, like the next question is, hey, why can't we do this for robotics as well? Because again, we have models that are working individually for individual robots and individual tasks. We've seen that in the 2010s. So now it's like, let's try to do it for, of course, I'm oversimplifying, but like, yeah, that's kind of the plan.